Previously on Student T. Yeah, we talked about a couple of reasons why we would use the Student T test or the Student T table. And one of those reasons, well, as we saw in the previous video, was to compare multiple, or to compare one sample that came into the laboratory that we've tested multiple times on two different methods. And then we said, well, there's an instance where a laboratory could get multiple samples, and we are testing these multiple samples on two different methods. And that's where this equation comes in, because we're testing more than one sample. We are testing, in this case, 11, and that was the example that we ended with in the previous video. So if I go back to the PowerPoint presentation, here was the table of data that we provided. And these 11 samples came through the laboratory door, and we had one group to test those 11 samples using one method, and maybe this aluminum content again was using ultraviolet visible spectroscopy. So these are the values that they gave us. And then the other group of people, again, maybe they used atomic absorption spectroscopy, reported the values back, and in the method 2 column, these were the aluminum concentrations that they were provided. So we look at these numbers and we kind of compare them like we did in the last video, and some of these are a little bit lower and some of these are a little bit higher. Some of these are more lower, some of these are more higher. It doesn't really matter. It's our job to figure out if these two methods are the same. So because of that, we introduced this equation and we said T-calc is equal to the absolute value of the difference average divided by the standard deviation of the difference, and then we multiply that by the square root of n, which is the number of measurements that we have in total. Alright, so if I go back and I open this up into Excel, what I've done is that I've just created an Excel document, and here are the 11 samples, 1 through 11, and these were the values that were given in the table. So this was for method 1, and method 1, I just transposed those numbers into here. Method 2, the same way, I just transplanted those numbers into the column. And we said that all of this relies on differences, right? This is the difference average, the standard deviation of the difference. That is where this is a little bit different than the previous example. All right, so I can get Excel to do that quite easily for me. So I've created a column here that says difference. And what I do is that I just hit equal, because I want Excel to do the calculation, and I open the parentheses up so that way it knows what to do. I like parentheses, right? Parentheses are my friend. And it doesn't really matter the order that you take the differences. Who cares? I like to go from left to right. So I'll do 17.2 minus 14.2. But if that really bothers you, you're more than welcome to flip that around and do 14.2 minus 17.2. It doesn't really matter. Tomato, tomato, right? Both of them are correct. The only difference, or the only thing that I will warn you with, is that you want to be consistent all the way through. So once you pick a method that you want, then you want to replicate that over and over and over throughout the statistics. So if I'm going to do 17.2 minus 14.2, that's this column minus that column, then I want to make sure that that's the same all the way throughout. Keep it consistent, right? So I do that and I hit enter. The difference there is a 3. All right, well, on the PowerPoint, you're going to see that that difference is listed as a negative 3. Well, what this person's done, they've taken 14.2 minus 17.2, and they've got a negative 3 as a difference. Either way is correct, and that is why I did it both ways, to let you know it's okay. It's okay. Whichever way you want to do it, it's fine. Just do it the way that makes you happy. That's all that we ask. Okay, so I can go down to the next row and I can do the same thing. I'll hit equal, open the parentheses up. I want to be consistent. So this is 23.1 minus 27.9. I close the parentheses up and I hit enter, and that gives me a negative 4.8. In the PowerPoint, I see a positive 4.8. That means these two people subtracted them differently. One did 23.1 minus 27.9. The other one did 27.9 minus 23.1. Again, Doesn't matter as long as you're consistent all the way through. Now, like a crazy person, I can keep doing that row after row after row after row, or Excel has a shortcut here that I can take advantage of. So I can click this last cell that I just typed in a formula for, and there's this small box in the bottom right-hand corner. If I click that small box in the right-hand corner, left click it, hold it down, and drag it all the way down the column, you're going to see that that column is highlighted now. Then I lift up on the mouse, and that copies that equation in every single cell. So that way I don't have to do it every single time. And then I can just go back and double check it. You know, this is B4 minus C4. That's correct. That's what I want. This is B5 minus C5, B6 minus C6, B7 minus C7, B8 minus C8, all the way down. So that saved me a little bit of time. I don't have to continuously put in that same equation every single time with every single calculation that I want. So that makes me happy, but that's also the power of Excel, which is why it should make you happy. All right, so now that I've done those differences, that's what this equation plays off of, right? It's the differences. I need the average of the differences, and I need the standard deviation of the differences. Well, Excel will allow me to do that. So I'm just going to type in average, and I'm going to type in standard deviation. That way I know which one's which. So beside of the average, I'll just hit equal, and then I type in the word average and open the parentheses up. And it says, well, what are the numbers that you want me to use? Well, we need the average of the difference. So that's what I'll highlight, and I'll hit enter. So there is the average of those numbers. Notice it doesn't matter if they're negative or positive. The equation utilizes those negatives and positives to do an average, and that's what I want. Standard deviation, I do the same thing. I hit equal, STDEV, and I open the parentheses up. And I need the standard deviation of the differences. So I will highlight that column and I will hit enter, and I get 6.748252. So notice how quick that was. I now have all the pieces that I need to solve this equation. So my average is 2.49. My standard deviation, let's just round it off to 6.75. That's okay, it doesn't really matter. So here is my T-calc calculation. So my standard deviation, again, if I go back to Excel, was 6.75. So 6.75 goes here at the bottom. This is the absolute value of the average. All right, so if I go back to the average, my average is positive 2.49. So absolute value didn't really do anything for me there. If I subtracted the opposite way, I probably would have gotten a negative 2.49, and that absolute value would have taken that negative out. So that is why I kept saying it was okay whichever order you subtracted in, because this step corrects for that, whichever way that you went. So square root of n is the number of measurements. There were 11 in total, so there we go. So I'm going to do this in baby steps. Baby steps are good in math, right? Who cares if it takes you extra steps? Who cares if you have to write a little bit more? I feel much better when I take baby steps on calculations. So do it. It's not going to hurt my feelings, and it probably is not going to hurt your feelings either. Who cares if your neighbor could probably do it in one fell swoop? Don't pay attention to what they're doing. Pay attention to you. You're all that matters. So 2.49 divided by 6.75, that gives me a 0.36. Let's round that off to a 9, right? So 0.369 multiplied by the square root of 11. Well, yeah, this is a computer calculator, so I don't really have a square root button on it. So I'm going to have to do this an old-fashioned way, or a little trick. So I have to do 11 to the half. That's the same thing as taking the square root of. So when I do that, that's 3.3166. Your calculator, though, if you're using a TI-83 or an 84 or higher, has a square root symbol on it. So you might as well take advantage of that square root symbol. square root of 11 or 11 to the exponent of 1/2. That's the same exact thing. It doesn't really matter. So 3.316, and then I'm going to multiply that by 0.369, and I hit enter, and I get 1.224. Let's round that off that way. 1.224. And that is my T calc. All right, now what do I do with that number? Well, my goal here is to figure out if these two methods are the same. And we said to do that, we've got to compare our T calc to our T table. So I'm going to have to go to our T table, and I'm going to have to pull off what that T table value is going to be. So it didn't tell us, but by default it's 95% confidence limit. Remember, this is degrees of freedom. So we had 11 measurements. So degrees of freedom would be 10. It's 11 minus 1, right? So here's my 10 measurements. We go over, or 10 degrees of freedom. So 2.228. That is the value that I'm comparing to, 2.228. All right, so 2.228 is my T table. My T calc is 1.224. So my T calculated is less than my T table. And because it's less than the T table, that means these two methods are the same. That means if one group did it by UV vis and the other group did it by atomic absorption, it doesn't really matter which method I use because the methods are telling me the same story in the long run. So I would probably pick the one that's cheaper, the one that's quicker, the one that's easier to use, because all of that saves the company time and money. And time and money means they can employ you longer, they can employ more people, or they can give you raises, and that is what you want, right? You got to think like a businessman here. Big companies are not out to get you. Big companies are what puts money into your pocket, and you need to appreciate that. And once you understand how those big companies work, then everybody can be a little bit happier, right? Who cares if CEOs are making tons of money, maybe more than you? But those CEOs have put in tons of more money into the company versus yourself. So they should be getting some big bucks, right? So time and money, that is what you always have to put first when you work for any company, whatever company that might be. So these two methods are the same, T-calc and T-table. T-calc is less than the T-table, so that means the two methods are the same. I pick whichever one is going to be easier for my people to use. All right, so that sums up the different reasons why we would use that T-table. So around 4. But our equations are not over. We still have 2 more equations that we need to talk about in this world of statistics, and why we would use them, and maybe why quality control would use them, and why they relate to good laboratory and good manufacturing practices. All right, so we're not yet done. We're almost there. Stay tuned. There's more yet to come. How many times have you heard me say that?